Question number 8 from Chapter 4, Form A, handout. We need to use substitution or elimination to solve the system of two variables with two equations. The variables are x and y. Let's see. Let's put this first equation. The second equation is already in standard form. Let's put the first equation in standard form and see what we have. So what I'm going to do is I'm going to subtract y from both sides to get, and then reorder it so that 2x minus y equals 4 for the first equation. And to see what's going on a little bit better, I'm going to write the second equation underneath it. Negative 4x plus 2y equals negative 7. Okay, I'm setting myself up for elimination. I want to add both sides of the equations, but I want to manipulate one of these equations. I'm going to focus on eliminating the y's or eliminating the x's. I am going to go with the y's. You can go with the x's. I'm choosing the y's. Two reasons. First, they're smaller coefficients. I've got a 1 and a 2. And I've got a negative and a positive. This one has negative and a positive, and it's a 2 and a 4. So I'm going to eliminate the y's. Now, how do I do that? If this is equation A and this is equation B, then I want to put a 2 here. Well, I just can't throw a 2 here. I actually have to take 2 times equation A and add it to equation B. So that's what I'm going to do. I'm going to take 2 times equation A. Whoops. Multiply 2 on both sides of the equation. So I had 2x minus y equals 4. There's the 2x minus y equals 4. Double both sides, I end up with 4x minus 2y equals 8. Now I need to add b, so I'm going to move this underneath, and I can add straight down. Wait a minute. What was I eliminating? I was eliminating the y's. That happens, but notice how the x's also eliminate. So I don't have anything left on this side. And on this side, so this is one of the special cases. If the system is inconsistent or has dependent equations, say so. So I don't have anything on the left side. Over here on the right, I don't have 0, I have 1. Now, is this true or false? It's false. Since this is a false statement, these two equations cannot be true at the same time. I can't solve for it. So this is an inconsistent system. And there are no solutions. Or you can say that it's the empty set. No solutions. Question number 9, Chapter 4, Form A. Question number 9 reads, 2x plus 3y equals negative 9. Consider that equation the same time as 5x minus 2y equals negative 13. All these are not 1. So I'm going to look at elimination. The x's are lined up, the y's are lined up, the equals are lined up, the constants are lined up. Everything's lined up. So I'm going to inspect the x's. I have a 2 and a 5. And the y's, I've got a 3 and a 2. I also have a negative and a positive. So I'm liking this one better. This one I'd have to multiply. So what number do I want these two to get to? I want them to get to 6. So my target is 6. I'll write that 6 up there. I want one to be positive 6, one to be negative 6. Good news is one is already positive and one's already negative. First one's positive, second one's negative. How do I get this to multiply to 6? I've got to double it, which means I double the whole. We'll list it A and B again. I double the whole equation, 2 times A. And how do I get this to 6? I've got to triple it or multiply it by 3, plus 3 times B. Now, since one's positive, one's negative, this will end up being positive 6. This will be negative 6 y's, and the y's will drop out. That's our goal. So let's double equation A. I'll do this a little bit different. Well, no, I'll write it all out. 2x plus 3y equals negative 9. So I'm going to write that over here. I get 4x plus 6y equals negative 18. Do not forget to multiply the other side. 3b is 3 times equation b. 5x minus 2y equals negative 13. 15x minus 6y equals, we got 3 times 13 is 39, negative 39. Now we add down. So do all that work, line everybody up. That's what I expected to happen. Over here, 15 plus 4 is 19 x's. And these two, when you add negative 39 and negative 18, you end up with negative 57. Okay, divide both sides by 19. I know the answer is negative. I am hoping it's a whole number, but it might not be. If it's not, that's okay. We lucked out here. X equals negative 3. You just keep going if it's a fraction. So far I think x equals negative 3. I plug it into one of the other equations. Original equations. Always go back to your original. I'm going to go equation A. 2x plus 3y equals negative 9. 2 times negative 3 plus 3y. I want to be solving for y here. Okay, I think the solution is x equals negative 3, y equals negative 1. Am I done? No, I need to check it. Let's see, let's check right here. Check negative 3, negative 1. The first equation, that's the one that's most likely to work since I used it in order to find y. But go through the steps, I'm going to have to do it anyway. Plus 3 times negative 1, negative 9, negative 6, minus 3 equals negative 9. Negative 9 equals negative 9. That one's good. Let's check the second one. 5x minus 2y equals negative 13. 5 times negative 3 minus 2 times negative 1 equals negative 13. Negative 15 plus 2 equals negative 13. Yes, negative 13 equals negative 13. So the solution is negative 3 for x, negative 1 for y.